All right, so now what we're going to do is actually take everything that we've talked about in the first 3 videos and actually just mix it all together. So you could actually have to do more than one type of factoring in a problem. Now, the first thing we started out talking about, remember, was GCF, greatest common factor. And actually, when you start any problem that you're told to factor, you always are supposed to check to see if you have a GCF. So that's going to be the first thing that we talk about with each one of these problems. And then we'll go from there. Do I have 2 terms that's going to be a difference of squares? Do I have 3 terms that will, be the trinomial? Or it may be that GCF is all that you can do. Okay, so the first example, you have 3a squared plus 9. That is a plus 9. And you probably have noticed every once in a while there's a random big blob of ink, something, whatever reason it does that whenever I print it off, so don't worry about it. Okay, so if you look at the 2 terms you have here, you do have a 3 that's in common to each term. You don't have any a's though, because this term doesn't have any a's. So you're going to factor out a 3, and that will leave you from this first term. Of course, 3 will go into 3 one time. And of course, you still have the a squared. Again, the 1 wouldn't have to be written. Bring down your plus sign, and then 3 will go into 9 3 times. And that's actually as far as you can go with this problem, is just GCF. I've got 2 terms, so like if you're talking about difference of squares, but immediately you know this is not a difference of squares for 2 reasons. 1, this is addition, and you'd have to have subtraction, and 3 is not on that list of numbers for perfect squares. So sometimes GCF is the only factoring that you can do. Okay, next example. Again, first of all, what I want to talk about is to see if you have a GCF, and you do here. You have a 7 that's in common to each of your terms. So if I were to factor out a 7, of course 7 will go into 14 2 times. Bring down your y squared. Okay, middle term 7 will go into 7 1 time. Bring down your y. And then your last term 7 will go into 21 3 times. Okay, so now what I'm left with inside the parentheses is a trinomial. So we've got to see, if we can figure out if it'll factor another step, in doing the 2 sets of parentheses. All right, my first term is 2y squared. Well, there's only one way to get that, and that will be 2y times y. So you can go ahead and put that down. All right, my last term is a 3. Well, there's only one way to multiply and get 3, and that's 3 times 1. So I know I've got to use a 3 and a 1 down here. I've just got to decide where it needs to go. And I think the 3 is going to need to go here, and the 1's going to go here. So let's make sure we got the right combination. So if I multiply the outside together, I get a 2y. If I multiply the inside together, I get a 3y. Now my middle term that I'm trying to come up with is a positive 1. So that would mean the 2 needs to be negative, the 3 needs to stay positive, and then I would need to add. Because negative 2 plus a 3 will give me a positive 1. So that means different signs, and that is what I need, because see, this last term is negative, which tells me different signs. Now, it's the 2 that needs to, or the 2y that needs to be negative. So that would mean I have to put my minus sign here, because if I were to do a 2y times a negative 1, that will give me that negative 2. Plus sign here, positive 3 times y would give me the positive 3y. So this would be the correct combination of what you need for that one. Okay, next one. All right, so if you look at your terms that you have here, you do have a common factor again, this time being a 4. So that would leave me with n squared minus 5n plus 6. Okay, so now I have a trinomial, so we just need to see if this trinomial will factor another step. So bring down your 4, do your 2 sets of parentheses. Now, this one's gonna be a little bit easier to figure out than the last one, and that's because, see, this has a 1 in front of your variable, and if you remember, that always makes it easier to figure out. So n squared, that would have to be n times n. Now, for 6, I've got 1 times 6 and 2 times 3. Now, you're gonna have to think about your signs on this one before you pick your pair of numbers. I need to have like signs. So that means both pluses or both minuses. Well, if I put both pluses with the 1 and the 6, that's a 7. If I put both minuses with a 1 and a 6, or both negatives with a 1 and a 6, that's a -7. So the combination you're going to need here is going to be the 2 and the 3. And you're going to need them both to be minuses to indicate that they're negative. So if you were to add a -3 and a -2, I mean, you can do the same thing we were doing earlier. You can still check it by doing the outside. See, that's a -2. The insides is a -3. So if you add a -2 and a -3, that does give you your -5. Okay? All right, next one. Okay, so if you think about a GCF, first thing that probably pops in your mind is your 6, but I would also factor out a -6. Remember, same thing I mentioned before. When you go to factor the trinomial or factor a difference of squares, you're going to want this, in this case it's a z, but whether it's a z or an x or a y, you're going to want it to have a positive number in front. So I'm taking out a -6. So that's just going to leave me with a positive z squared minus 100. Of course, 6 will go into 600 100 times, but then your plus changes to a minus because you're bringing out a negative. Now this time I've got 2 terms. So the only thing we've discussed factoring with 2 terms is a difference of squares. So this is a second power. This is subtraction. Remember, that has to be subtraction. If you go back and look at that list of numbers, 100 is on that list of numbers. So this is a difference of squares. So z squared is z times z. 100 is 10 times 10. And remember, on a difference of squares, you always have one of each sign, one plus sign, one minus sign.